Hey kiddos, it's Miss Lloyd, and because y'all are out for class on Friday, I'm doing this before Friday. That means that you're not gonna be in to get all of my wonderful anecdotes and jokes and whatnot. So I have made this video to compensate. So we're looking at 3A and 3B that we're going through. Originally, there was also supposed to be 3C, but one, I didn't want to make a super long video, and two, I didn't want you to miss too much because, like, even in class, you've got like the questions that you're able to ask, and you can't, I mean, you could ask the video a question. I don't know, I don't think it's going to respond, but you can always email me your questions as well. So we're looking at relations and function notation. So a relation is any set of points in the xy plane, so that coordinate plane. And the points are going to be a way to connect or form a relationship between x and y. So we know that there's a relationship because we can see the points themselves. So there's a relationship at wherever these coordinates are. So maybe it's 4 comma 3. That's a relationship. That's a relation between x and y at that particular point. We can also see them as inequalities. So we could have where x is greater than 0 and where y is greater than 0. That relationship where they're both of those things at the same time is all in the first quadrant. So it could just be like a massive shaded region here where x and y connect, where they are the same thing. We also see it in equations all the time. This one is like a sine or cosine function, one of our tangent, or not tangent, one of our trigonometry functions. Because this is at 0, 0, it's likely a sine function. But depending on the shift and whatnot, it could be a cosine as well. That's been shifted. Anyway, so equations, be they trigonometric or quadratic or cubic or any of those, these are also relations on how x relates to y. Do they relate through a function like tangent or an absolute value? Do they relate in some other way? And if at any point, you know how videos work, you can pause and rewind and slow down and all that stuff if I'm going too fast. A function is a relation that has no x values with multiple y values. So basically, you can't have an x value that repeats with two different y's. And also, a function and a relation, think of a relation as a rectangle. In this case, if a relation is a rectangle, then that means a function is a square. This means that a function is always a relation, but a relation isn't necessarily a function. And there are a couple different ways that we can tell the difference between is it a function or is it not a function. We have a couple different tests we can do. So if you have the points written out and you see, oh, I have the same exact x value, that -3, with two different y values, then okay, I know that this isn't a function. Yes, it's a relation. I can see the relationship between x and y, where x is and where y would be according to that x. However, it's not a function because of those repeats. A way to tell visually if a x value is being repeated with two different y values, we can draw it out. And we're asking ourselves the question, can I draw a vertical line that cuts my graph more than once? So I'm going to use, my vertical line here. And this is a hyperbola that I have drawn. And I can see that there are several places where I can draw this vertical line and it's hitting more than once, it's hitting twice, which means wherever that x value is, I have 2 points, two different y values, one positive, one negative in this case, where I have the same exact x value. That means that this is not a function. It's still a relation. There's still a relationship between x and y and how they work with each other. That is a hyperbolic relationship because this is a hyperbola. However, this is not a function. And I know you could say, oh, but Miss Lloyd, you can move this and then it doesn't even hit at all. Yes, however, we're looking at, is there any place on that graph where it hits more than once? Yes, we have a place where it hits more than once. That means that it's not a function. Say instead I had a line. There is nowhere that I can drag my vertical line where it's going to hit more than once. It's only ever going to hit once. I can also do the same thing for a parabola. As long as it's a happy or a sad parabola, not a drunk sideways parabola, I can again pick up my vertical line, and no matter where I'm at, it's only ever going to hit a maximum of one time. So this one is a function because it doesn't hit more than once. We also have some instances where we have, like I said earlier, a drunk parabola. So it looks like this. This is similar. This isn't the exact equation for this particular parabola, but this is an x is equal to y squared parabola. And so we can see here that there's multiple places where I could move and I would hit more than once my vertical line. If I don't have a visual, if I don't have a graph of my relation to see if it's a function or not, we can plug in any value for our x and start to solve for our y values. If we solve for our y values and we end up with multiple solutions for y, so like plus minuses tend to be a very common situation. If we have multiple solutions, then it is not a function. If we end up with only one solution, there's no plus or minuses, and it's not because we forgot a plus minus, there just isn't a plus minus, then that means that it is a function. So for each x, there should only be one unique y value. There shouldn't be multiple y values. So putting our understanding to the test, we're going to determine whether the relation that we see represents y as a function of x. So is this a function? Looking at this, again, whenever I'm trying to figure out is it a function, I'm paying attention to those x values and making sure that they are individuals and that there isn't any that's repeated. So it looks like I go 3, 1, 0, 2, 4. Well, it's not in order. That's fine. It doesn't have to be. None of these x's repeat. So because my x's don't repeat, this is a function. The next one, I have an equation. And so I'm going to plug an x value into my equation and see if I get multiple y values for my solution. So, and you can pick any one you want. It really doesn't matter. I'm going to say 0 because that sounds like fun. And I end up with one solution. So I wasn't taking any square roots anywhere in order to get rid of my y value. That tends to be the thing that jumps out at you. If you are solving for y and you have to take a square root, you're going to end up with a plus minus, so you have multiple solutions. I didn't have to do that. I only have one solution for my one x value that I plugged in. So that means that this is a function. This next one, again, I have an equation, so I'm going to plug in a value for x. 0 is my easiest. So here I can see because I have this plus minus, that means I have two solutions. That means that this is not a function. If I want to look at a more visual representation, so we're trying to determine if any of these graphs represent function. So y is a function of x. I'm going to draw my vertical line test, to see if there's any points where it hits more than once. So here I've got, what, 4 times that it's hitting, which means it's definitely not a function. I'm going to do the same thing for this next one, and it's a happy parabola. No matter where I move my vertical line, it's never going to hit more than once, so this is a function. I've got a line for part C, or for graph C, and there's nowhere I can move it to where it's going to hit more than once. So this is also a function. And last but not least, I've got an oval, or you could also call it an ellipse. And there are places where if I had my vertical line, it's going to hit more than once, which means this is not a function. Now that we've got an idea of function versus not a function, we're going to look at function notation. So if we know that an equation is a function, so we could do the test to prove it, we are going to, instead of having y, we use f of x. So basically, mathematicians are what? Lazy. Yes, I know. And because mathematicians are lazy, we were so tired of being like, okay, if my equation is y is equal to, I want to plug in x is equal to 7. They wanted to shorten that. So instead, they start using the function notation. So then that can tell us, okay, I can see when I'm plugging 7 in for x. Instead of this x here, down here at this example, we're plugging in 3 instead of x. That's a shorthand for saying we're plugging in 3 for x. X is equal to 3. We also use this to denote if we are doing inverse functions. Instead of writing out the words inverse function, we have symbols that we use with this f of x. We also do the same thing when it comes to derivatives and integrals. This function notation helps us to use shorthand for what we're doing to a function. So my first example, they say, okay, if this is what we're saying our function is, find the value of f of 3. So that's how it said, f of 3. So that means that they want us to plug 3 into all of our x's in the original function. So everywhere I have an x, I'm plugging in a 3. This does not mean that f is multiplying with 3. That's not the same thing. This is saying that for the function f, and it doesn't have to be an f, it could be g or h or anything like that, but for this function that we have named f, we are plugging in 3. And when I plug it in, they want us to find the value of, so I'm doing all that simplifying. And my final answer is going to be left with that f of 3 notation. So this is telling whoever's reading this that for the function f, I plugged in a 3 for my x, and I ended up with a value of 39. This is our final answer. We're going to do the same thing with the -2. I highly suggest that you pause the video and try this on your own, plugging in -2, and then you can unpause and see what I did. Check yourself before you wreck yourself. And then we're done. Also, instead of just plugging in a number, there's a possibility that you could be asked to plug in a binomial or something that has a variable in it. Sometimes it's the same variable x, sometimes it's a different variable. It could be g, it could be m, it could be something like that. Especially if instead of an x, you're using measurements of some sort. You could have h's for heights or w's for widths. That's a possibility, so don't let it freak you out. So for this first one, instead of x, they're wanting me to replace x with the entire binomial -x plus 3. So now that I've done that, I can start simplifying. We start with our exponents, which means I'm writing this x minus 3, sorry, -x plus 3 out twice to do the multiplication. I'm also going to do some distribution just to save some time. And I'm going to make sure I keep my notation. Now I don't forget it later. Doing my last distribution and simplifying. I can see my final answer. And most students don't appreciate this as a final answer because you feel like you are supposed to get a number, you plug something in, you should get a value in return, but this is the new function that we have. Again, I suggest you pause and do B and C, and once you've done, unpause the video and check your solutions with mine. All right, if after all of this you still have questions, please make sure that you email me and let me know, and I will do my best to help you out. I hope you all have a wonderful time in London. If you come across any of my TASIS kiddos, be sure to tell them that I said hi and that I miss them. I hope you have a wonderful weekend. Stay safe, make good decisions, and have tons and tons of fun.